Yes, because the next speaker is, I don't think he's here, is Ayman Alnaerat, unless he's using a different name again. But if he's not here, then I suggest Lucas, because he's lined up just after. If Lucas can present his second paper.
Okay, can I have 20 seconds just to
Yes,
open
yes, take your
all
time.
the resources here?
You can
Yes.
breathe. You can breathe. We let you breathe.
And if by chance Simon appears midway, he will go after you. Because just after that we have a break and then the workshops.
So we have a bigger break. You can eat something.
Yes, yes, that would be good. Yes, that's a very good suggestion. Food is always welcome, right? Okay, so
For me,
Lucas,
yes.
whenever you're ready, you can start, but take your time, okay?
So many good things this year in GHU.
As always.
As always, it's true. That's true. That's true, as always.
Okay,
So, Lucas, just tell me something. What do you teach?
I teach physics and science.
Physics. Okay.
Yeah,
Okay.
that's the first physics curriculum and science.
Yeah, okay.
Can you see my screen now?
Yes, we do.
The browser.
Okay.
Okay, no, yes.
All right, so I think you guys are seeing. So it's only the slide, right?
Yes.
Okay. So now I'm going to talk about the Pulsar 3D simulation. This is a simulation for my master's in physics for the University of Brasilia. It took me 6 months to create this simulation. It's a simulation based on the JavaScript language, and it was hard sometimes just to figure out how to create all the interactions and to use 3D with JavaScript. So it was an adventure, and I'm presenting this for the first time, and no better place than here to introduce the simulation. So this is an introduction to an interactive 3D environment of pulsar characteristics. So the whole idea is to use the simulation to learn a little bit about pulsars and how do they work and who discovered them, what was the implications in astronomy, what is the structure, so on and so forth. Okay, so right now, if you want to access the simulation, I'm going to put this QR code here. You can use your smartphone or tablets. This is a responsive application. It works in PCs, smartphones, and tablets. As you can, as long as you access the simulation, I'm going to show you. You can go to Google and put Pulsar 3D simulation. And then the first link is the GitHub page of the project that you can access. So it's called Pulsar 3D simulation. And then here we have all the source code, the files, we have the images that I used. And this is the screen of the Pulsar 3D. So you can click and can interact. These are buttons on the right corner. Also sliders like speed and ambient light, like inclination, tilt axis in this case. And as I said, these are responsive. You can use in your classroom, in your teacher computer or student smartphones, gadgets, and even on tablets. So here on GitHub, we have the whole documentation. For example, what is it, the definition, how to use the controls. We have the dynamics, and you're going to see that I tried to use to mimic a real 3D environment. So I used 1.7 billion stars. It's a real photo for the Hipparcos dataset, Tycho and Gaia datasets, real photographs for the background. And I'm going to discuss a little more when we open the simulation itself. Here we have some education, scientific terms, the definition. Here's Jocelyn Bell, the Miller Observatory in England, the first detection of the Pulsar CP 1919. This is the hand letter from Jocelyn Bell. Also scientific definition, some institutional information about the master's program, and we are trying to launch this and to patent this here in Brazil. So you can click both in this link on the right on the GitHub page after you search on Google Pulsar 3D simulation, or you can go here after the definition and you click on this link. So this is a GitHub page and that you can create your project, and then off we go. We have this initial page like a landing page. We have the welcome information. You can click with the right button if you are using Google Chrome and translate to any language you want. In this case, I'm going to translate to English. So welcome to the Pulsar 3D. You can enter the simulation. This is a three-dimensional experience, an interactive simulation. And then there we go. This is the Pulsar 3D. This is a translated version of it. So we can adjust the light of the background and the ambient around. We can click normally and just drag, and you're going to see that we are in space. These are real images in the background, right? So we can have this feeling of being in a three-dimensional environment. But besides of that, I try to just teach my students what is a pulsar, what are the characteristics, what is the physics behind this astronomical exotic object. So we have these pulses of radiation being emitted by the pulsar. So this is a particle interaction and lines in JavaScript. You can adjust all the settings to create this very cinematic looks, which is amazing. And just for students to understand that it's a rapidly neutron star rotating very, very fast. We also can control the speed that it's revolving, just to show them to understand the concept. And then, for example, like a real pulsar, how would they behave? In this case, we also can show the structure like a thin atmosphere. I'm going to talk about this, and this bluish like star texture that use it as a 3D object to mimic the pulsar itself and the cones of radiation. And my students, they always ask, hey teacher, can you do the Star Wars thing? So they call this Star Wars. If you go position the camera, just click and drag direct on the radiation, you can just follow the path of the radiation, for example, towards the Earth. If we go full screen, this goes like very Star Wars kind of feeling. Okay, so we can show students a very interactive 3D environment, but we also can show them like very important things like the grid. Here we have a grid and we have a rotation axis, and we can show them by selecting this axial tilt an inclination slider, how the inclination of the pulsar interacts and affects the behavior of pulsars. Okay, just like this, you can just find where is the pulsar. For example, let's pause here. I want to show exactly when this passes towards the Earth. So you can just use this to show students the pulsar behavior in a very schematic way. Let's put it like this. So all the colors, all the design, the virtual um, presentation of it was based in on this image right here by National Radio Astronomy Observatory, and they have a very nice content about pulsars itself. This is a translated version that I did for the Portuguese teachers. And if you click on the titles, it can expand and you have the definition. And so this website creates this all immersion. It's a class about pulsars. And we have, for example, who discovered and observed the pulsars. We have a New York Times documentary about Jocelyn's discovery and career. Very good uh, resource to show in your classroom. For example, we have the scale of a pulsar, like density, very fun aspect to work in classroom. For example, this is basically the size of Brasilia, like a 20 to 30 kilometer uh, in diameter city, just like a small city in Europe. And then we have the neutron star. Try to imagine the mass of the sun compact to the size of a city. So this is absurd to think like that. Also talk about the life cycle of the stars, how do they form, and at the end we have the structure of the pulsar. This is a nature image, and we did this translation just to understand like the atmosphere, these atomic nuclei and free electrons, and then the neutrons in the other structures. And until today, we don't know what's in the core, what's inside a neutron star. So these are very dense matter, and it's still a mystery. And I think that is fascinating. But we also have the jets of radiation, and based on this application, the Pulsar 3D simulation, we have the idea, me and my professor, her name is Vanessa, we created a lesson plan, okay? And this lesson plan, I'm going to share with you both the link, I'll put the link on the chat, but also I want to show this lesson plan for middle years and high school, and graduate teachers, you can use it too. Undergraduate teachers, you can use this in undergraduate education. You have a 50-minute class. These are the materials. Basically, you have to access the simulation to show students. They need internet access to open the simulation in their devices. And first of all, the teacher preparation. What teachers should do in this case is to familiarize with the working of the simulation, just like the buttons, the halt texts, images, and controls. That this is going to make it easier to use in the classroom to show students. So they can just like start asking students what they know about stars and these excellent exotic astronomical objects like neutron stars, pulsars, black holes. This is a very interesting topic that they always ask in the science class. And for example, make questions like, how do you think a pulsar's rotation affects its surroundings? So try to imagine in loco. Try to imagine being there close to a pulsar. What's happening close to a pulsar? What is the behavior observed? And what is the difference between being close to a pulsar and here on Earth? What is the difference about the structure, the signal, the electromagnetic waves that we observe them? So these are the hands-on. They're going to enter the simulation, open in their devices to use just to feel it, the sensibility, all the controls, okay? A guided exploration, just focusing on the magnetic field. Just sorry, I didn't show you the magnetic field, but here you can click on magnetic field and you have these lines interacted here on JavaScript. It was the most difficult part to create because these are interlaced and interpoled data set in lines here on JavaScript. It took me 2 months to create. It was not that simple. I have to do a lot of research to try to create them and use actually the Pulsar's formula for magnetic field. So this is a simple representation. It's not that uh, complex or very scientific in sorts of speaks. It's just a virtual um, resource that teachers can use to stimulate students to make them understand very clearly what is a pulsar. Okay, back to the lesson plan. We also can do scenario exploration using the rotation speed, the axis tilt, magnetic field, and then comparing with real data, just like this link right here. We can use this just to compare with this data set of a pulsar from Freeman, and then to show them what is the pulsar detected by radio telescopes here on Earth. All right. At the end, we can provide a quiz with the different questions for them to understand and to answer in group, like what is the size and magnitude and density of a pulsar, the structure of a pulsar, what part of the EM spectrum astronomers observe pulsars, what causes the pulsar to emit regular pulses of radiation, and how does the pulsar magnetic field influence its surroundings, so on and so forth. And finally, ask them to explain all this behavior in paragraphs, or you can try to ask, for example, what was the impacts about Jocelyn Bell, Jocelyn Bell's, the impact on their discovery and what happened to her. Do you think it's fair? What happened? And then use all these resources available, especially this essential radio astronomy with the pulsar definition, very good material. And this material, I'm going to put the lesson plan on our chat right here, our chat. Let me just put it here. Okay, there's one, and we have the Pulsar 3D also. All right. If you want to access this page for you to download the lesson plan, you can use this Zenodo page right here. It is published there, and you can just download both in English and Portuguese. So it's available for English and Portuguese. All right, we have the two links right here. We have it done, everything. Okay, just stay right here. And all right. Okay, Rosa, I think that's it.
Wow. Wow. What else can we say? This is amazing. Really amazing, amazing work that you've done.
Thank you so
Amazing
much.
that you're using this with your students. We have a project that is just starting this year called Astro Journeys, where we are making a kind of repository of resources that invite students to have their hands on research. So I will invite you to share your material to Astro Journey and maybe spice it up a little bit by adding a component of inviting students to make the light curve of a neutron star that we know is
Okay.
a pulsar to the collection that you have. So we have a complete set for the Astro Journey, but I will certainly contact you.
Okay, thank you.
Great job, Lucas. It's very, very lucky for us that you came and present. This is what we want in with this space. We want people to come and share these beautiful ideas that can inspire others and that can instill this perspective that it's possible to be done, especially because you are a teacher, you've been doing this with your students, so we know it's possible, it works, and it inspire the students. So I see here on the chat claps and Hassan from Morocco saying, wow, excellent work. Maria Luisa from our team also clapping. And let me see on Facebook. We don't have comments here, but I'm pretty sure. I also shared the links that you shared here on Facebook. So people watching from there have the possibility to see. So Petros, you shared to me, not to everyone, but I will read to Lucas. Thanks and congratulations, dear Lucas. I see you use an English version of your application. Is there a way to toggle languages? The app is really amazing and very inspirational for sonification purposes. Congratulations. I know that Petros is from Greece, so I am sure that he would be delighted if this application can work in Greek as well.
Okay, Petros, actually, you can translate using the web browser translator. For example, in this case right here, I just use the Google Translator. Okay, but we can try to use this, for example, in Greek. Okay, you can try here. Just G, go to G here, and you can translate it. There, that is. So you can translate it to any language you want, right? It's a little difficult for me because I do not speak Greek, but all right, you can translate to Indian, any language you want, Chinese, Japanese. Okay. All right, Hausa.
Thank you very much, Lucas. That was amazing.
Okay, guys, thank you so much.
We are very glad that you came and shared. And Gustavo, the floor is back to you.
Yes. So we don't have here the previous presenter, which was Ayman. He didn't show up, so that means we'll have a longer break.